So we've been talking about this partnership with Thales Alenia Space, and what better transition to have on stage now Franck Perrin, Cybersecurity Director for Space Program at Thales, one of our sponsors. Thank you for being here. Franck Perrin will tell us all about securing the space segment in modern SATCOM constellations, threats, vulnerabilities, and emerging technologies. The floor is yours.
Okay, so thank you. So effectively, I am Franck Perrin. I am the Cybersecurity Director for the sovereign cybersecurity technology of Thales, and so I am especially dedicated to the space system security. So I hope it works.
Green button.
Green? Yes. Okay. So we are just going to talk about the space segment for cybersecurity and for what I call the modern SATCOM constellation. With the term of modern, it's just because we have a real big change in technology and also in architecture within telecommunication satellite. So we are going just to see what are the modern SATCOM constellation and the major move between the old or the legacy geostationary satellite system and the new constellation. And we will have a quick overview of the threat and vulnerability links to those new constellation, and at last, the emergence in technology, and maybe, I think the most important is a real new approach we have to take into consideration to securize a space segment. So first of all, what is a modern SATCOM constellation? So the first slide is to say, okay, so from the legacy GeoSatcom system, so I can say once upon a time, there was a geo satellite. It was only one or two, or I would say not so many satellites, with a direct link to a control operation center, which cover both the satellite control system and also the mission control system. And then you have the end user plane for the communication of the end user. If we take this configuration, a few years ago, there was not a lot of communication between this end-user communication plane and the control system. And if we take the onboard part, most of the satellite configuration was some analogic repeater based on some electronics components. There was not a lot of software on board. The most important thing is we had a transparent user communication, so there was no computing on the communication of the user from the onboard. And most of the time, the platform was managing all the TTCs, the security for the platform and the payload, and was, I would say, the major part of the satellite. And for the ground, nearly we can have only one global command center with some limited change of the configuration of the payload, and nearly, I say nearly because it's not really true, a nearly closed ground segment. So we can say at this time, life was simpler than today. What do we have today with some modern SATCOM constellation architecture? First of all, we have really many satellites. So it's many hundred, or it can be many thousands of satellites with some inter-communication links. And also, it can be used as a relay with the standard geostationary satellite. If we have just a look now on the ground part of this, the main change is that we can have a real separation between the mission operation center and the satellite control center. It could be on even different sites. The payload could be directly operated by the mission control center without using the direct TTC from the satellite control center, but there is still some exchange between those two command centers. If we take now the user plane, you have a real need of online communication between, I will say, the user operation center and the satellite and mission operation center, because there is an important need of communication of the needs of the user plane, and so to make some configuration adjustment of the mission. So the main different part is, first of all, on board, you have now lots and more software on board. This is very important, and you need to have an important computing capability on board, especially for the payload. You have some regenerative payloads. This is also very important. With the 5G NTN, you need to have an onboard computing of your user segment, especially for authentication of the services or the devices, so it's no more a transparent plane. So this point is very important because you have a direct access from all the user terminals to an onboard computing part. And at least, if we now have a look at the global onboard architecture, we have no more the platform and the payload, and that's all. And the platform is managing all the cybersecurity. Now the onboard has become a real complex system with the platform, the payload, also you need that, but you need also to deal with inter-satellite link, both for the TTC and also for the user, and you have also to manage the user plane security needs on board. If you take the 5G NTN, for example, you have some control, some monitoring and control of this user plane that is also part of this user plane. And at least we have new onboard technology. So it can be very funny to say IP or Ethernet or Linux is new technology because it's absolutely not new. We are using this technology for the on-ground, but it's very new for the onboard activity. For the ground part, I will go quickly on this. We can have some really distributed command center with a great need of exchange and online exchange between all the segments, just to adjust the communication, the configuration, and so on, especially in the case of a constellation with hundreds or thousands of satellites that are moving all along, and so when you need to readjust the routing table and so on. So this is a major change, and this is maybe the most important point to have in mind. We have a real, I will say, architecture and technological change that is a real disruptive, I will say, architecture for the space segment. If we take the thread, so this time we have some things that is written very small, so you can't read it, so it's nearly normal. The main idea with this slide is to say if we can have a global look about the threats for satellite system, if we take the risk origin, the first part of the slide, we can see that the source of the origin are very large. You can have really different actors for different reasons that can be a real threat sources for all the satellite system. The second part is very, very interesting, especially when you are working on a SATCOM constellation for a European commercial and sovereign activity, because with this, the type of target you can see as more than 80% is both commercial and governmental. So this shows us that for this kind of constellation, it's a real target for all the different threats. So the security and the cyber security of especially commercial and governmental SATCOM constellation is probably one of the most important points also we have to take into consideration. We are not seeing a lot of the military, maybe just because we don't know exactly what's happened. But for the commercial and sovereign, it's a very important part of the target. And the last one, part of this slide, is also interesting because it shows that for sure, ground segment is I will say, the easiest point for performing some cybersecurity attack on the satellite system, especially with the distributed ground system and with the needs of, I will say, of exchange to adjust the configuration. You have many and more, I will say, possible entry point and vulnerability to exploit. So for sure, the ground segment is still the main entry sources for cybersecurity attacks. But we see on this slide that 6% is also the direct space segment. And this is very important just because even if this slide has a few months old, it shows that now the space segment could be also the direct target for an attack. And this 6% just for now is only what we are seeing now, but for sure this percentage will increase in the coming years. So we need, the very important thing is say, we need to protect the satellite system, and especially the space segment, even if, I would say a few years ago, nobody was really afraid of a direct cybersecurity attack on satellites. So this is, I would say, a classical slide where we can see the different kind of threats that can reach the different telecommunication satellite. And one for me that is very also important is the malicious software onboarding that we can see for both payload and platform. For the payload is much more important because as we see, we have more and more onboard computing for the payload, so we have more and more software and needs on it. We also have some different software on board. For example, if we are talking about the software-defined radio, this means that we also have some software not only on the payload or on the mission computing, but also on the means or the equipment you are using on board of the satellites. It's so very interesting to have some codes and some software like this, but we need to have in mind that with each kind of software or new capability, when we are talking about flexibility or reconfiguration, online configuration, always new capacity come with new threats. And so we really have to take into consideration this kind of threats. And for sure, you have also all, I will say, the legacy threats that have not disappeared but are still there concerning the RF link. And so you have some threat on link interception, hijacking, and some command and control injection directly on the RF part. So if we take just this, I hope I have make a good summary. First, you need to take into consideration all the legacy threats. So you need to, have, for example, have some cryptography to protect your RF link or communication from the ground to the onboard, for sure. And you need to keep all the classical legacy protection, and because the legacy threats are still there and will not disappear. But we have more and more new threats due to the dynamicity of the system on all segments from on the space and the ground. As I was saying, if we have a look on the space segment, we have now some direct or indirect threats that have to take into consideration. Most important part, the regenerative payload. As I was saying, you have onboard computing, payload processing, or hosted payload also processing, with direct access from the user plane. This is a real new kind of threat we have to take into consideration. You have the inter-satellite link, as I was saying, for routing the TTC, but also the communication link. And with access from the satellite mission center or control center, so that can be used to spread a different kind of vulnerability or threat. And at last, the 5G NTN, as I was saying. So we have a more and more complex onboard architecture, software, with more and more communication for the TTC from the satellite control, payload control, and even the user plane that also is the certain, I will say, command and control that also is a threat on board. So this means that you have a higher exposure to the cybersecurity threat for all the onboard and so for the space segment. If we have just a quick look on the vulnerability, so as I was saying, for sure, the classical vulnerabilities are still there on the RF link and on the ground. On the ground, in fact, I would say you will you just have to reinforce the cybersecurity of the ground with more defense in depth, segregation, and so on. But it's not so far as classical cybersecurity, I will say, consideration for both protection and detection. But you need to adjust your ground segment with the, I will say, classical cybersecurity issues that you can have on all classical IT systems. But if we take the new vulnerability, most of them, for me, is on the space segment. And you have the regenerative payload. You have some new technologies that can be a threat, like the quantum computer, because when we are talking about quantum computing or quick ID, it could be, I will say, a new capability for the quick ID just to offer a new secured communication activity. But the quantum computer is also a real threat on the cryptographic. And so this is what we have also to take into consideration. And we have discussed about the PQC, and we will see later that it's part of the solution. And the two latest, I will say, vulnerability, the software vulnerability on platform, payload, and everywhere, I will say, on the space segment is really new things to take into consideration. And lots of inter-buses communication between many sources on the space segment, because you have to exchange between the platform, the payload, but now also with different satellites, with the inter-satellite link, and with also the user communication. So the idea here is that the new architecture we have on board, Induce, is absolutely required to face all those new vulnerabilities. For the emerging technology, I will not talk about the quick ID just because for me it's, I will say, a new secured communication services. So it's more a new part of the of a payload system or hosted payload you can have. So it's, I will say, it's okay, it's a new technology, but for me it's not exactly the new technology we have to take into consideration if we are just showing, watching at the system protection of a satellite. The first one is the post-quantum cryptographic. As I didn't say, it's just there to face the threat of the quantum computer, but you need to have an, I will say, hybridization of those new algorithms with also the old one, just to be sure to have, I will say, a sufficient level of cybersecurity, just because even if we have now some validated PQC algorithm, we don't have, I will say, the experience or the time sufficient just to be sure that there is no vulnerability with them. So the important thing we have on those new kind of new technology is, okay, we need to be able to take into consideration those PQC algorithms, but with a full update capability of this. This is what is a little bit new also, that we need to be able to update the algorithm, just because if we discover a vulnerability of an algorithm, we absolutely need to have a secure way of updating this capability. And for sure, for the other part of the cryptographic, we need also to be able to make some key upload, but also some firmware and software secured update of all the components. This is also very important and the thing we have to have in mind for all the new components we will provide on satellite system. We need to be able to fully update all the parts of the system. The second part, as I was saying, IP and Ethernet, absolutely not new, but totally new on satellite system. And what is also very important is that we need now to have, when we are doing some spacecraft design, to have in consideration, I will say, the new architecture and the new segregation we have to design for the satellite. Not only think platform and payload, but say, okay, we have now a new full architecture with some different components, platform, payloads, inter-satellite link, and so on. And so we need also to take into consideration those new technology, IP and Ethernet, to bring some protection. The last part for the emerging technology is the artificial intelligence. We have lots of artificial intelligence for, I would say, the mission, directly, for example, for the observation. We can use some artificial intelligence for the payload, but we need also the artificial intelligence, we will see just after, for the cybersecurity onboard detection. So this is a link to the last change that will describe the new approach, how we need to approach the cybersecurity now of space segment. The first thing is to realize that things have changed. It's easy to say, but we really need to have this in mind, and it's a real, I will say, a disruptive change. It's not a simple change, just a technology upgrade. So this is the first point that we have to take into consideration. We have now a real complex onboard design and a complex system onboard design. So the design for the onboard has to be done at a system level or an onboard system level, and not to rely, for example, on the platform or on the payload, because for new constellation, there is some different needs, even for platform and for payload. For the new technology, when I was talking about, for example, net IP or Ethernet or Linux, you can see on the payload, it's there that we have the most important change. We can talk about IP communication directly for payload. We can talk about direct Linux with container. On the other hand, for the platform, we have not the same needs of computing adjustment, and so we see in the classical design for the payload, the platform, control, maybe the old technology will probably be there a little bit more time. So you need also to cope with an hybrid approach of the onboard system, with both, for example, needs for IP communication and CCSDS. And you have also to think about where is the most important consumer, for example, of the cryptography. It used to be the platform, but for new system, the payload is will say consume, really maybe will be the major consumer of the cryptographic. So if you want to provide a cryptographic solution for that covers the global onboard needs, you need also to take the needs from the different parts and to provide a solution that cope with the two needs. This is very important. So for the two last point, I will say, the first one is maybe one of the most important. We have to take into consideration the threats that we know today. For sure, to face all those threats and those vulnerabilities. But you also have in mind that in space system, even with constellation, with, we'll say, a faster way to develop and put in orbit some satellite constellation, you also need to think about the threats that will be, or the vulnerability that will occur in 3 or 4 years. Because the design you are making just for now have to take into consideration the threat in 4 years. The example I have on this is that, for example, we have done studies with ESA. It was in 2019, if I remember well, where we have defined the cybersecurity need of the future space mission. And at that time, we have in mind the possible use case, so how the satellite and constellation could be used in 6 years with the technology, and we provide some solution. And if you take the hacking of the satellites that has been done in CYSAT 2023, this use case with the use of a vulnerability of the payload, the upload of a malicious code, and after the use of the CAN bus to reach the, I would say, the platform part, was one of the use cases we have defined 6 years ago. And so to react to this, we have not defined the exact attack, but we say we need for that to provide some protection to be able to face those kind of attack. And so we have defined some protection and detection solution for that. So with an onboard upgrade of the segregation between the platform, the payload, but also by providing some detection solution. At that time, it was based on at least some on-demand integrity control. But if we are thinking just for now of the detection we will need in 3 years, it will not be sufficient. We will need to have at least the same kind of ground detection with IDS, with sensor, but also based on artificial intelligence, just because there will be more and more activity and things that you will not be able to detect only with static rules or FDR. And so you need just for now to provide a full architecture for onboard with both protection and detection and a new architecture. So this is the really real important things we have to take in mind. New architecture, new technologies that will be able to face the threat in 3 or 4 years. And at least, but it's not really new, you need to be able to upgrade and to update all the components you are putting on a satellite with, for sure, a secure way for that. I think, yes, it's finished. And nearly in time.
Thank you very much, Franck Perrin. We can greet you. Thank you very much. We'll still have a bit of time for questions, and we have one. So you're a recognized expert in cybersecurity applied on satellite systems, and from an engineering degree, you became a national practice leader within CYSAT after specializing in backup and high availability solution. You joined Thales 15 years ago, and you've been in charge of setting up and operating, it's important, Thales Group's first security operations center. And you were also a program manager, and we know about your current responsibilities. Thank you for telling and explaining to us how we need to embrace change, because you said that life got more complicated, but fortunately we have indeed some solutions. And a question from Cesar Carmona: what are, in your opinion, the most efficient measures to prevent DDoS attacks from legitimate user terminals on SATCOM constellations, and what would be the main vulnerabilities on the routing algorithms?
Okay, so effectively, this is the main threat. It's not exactly the threat on which I'm working, because I work especially just for this on the space segment. But this is more, I will say, some vulnerability on the user segment. You will say the user segment is probably the most important because it's where the service is delivered. So the denied of the attack in denied of service on the user terminal on SATCOM constellations, the main important for a threat, if I take only the satellite part, is effectively how we can monitor the activities on the onboard part, which is in link with, for example, the 5G NTN network, and also all the monitoring and control tram. And this is where, for me, this is what is very important, to have also some artificial intelligence to be able to detect, to provide some detection, especially on, I will say, the user part, in fact, the payload part. So this is for the onboard. So this is the things that we have to be able to control on board of the satellite, but need to be very close of the 5G security framework. And for the terminal, it's not my specialty, so there is other people from Thales that can provide some better answer. I could ask them.
Thank you.
But not yet.
And for the 20 seconds we have left, a question from Eric Perrier de la Bâtie. What about the vulnerabilities related to GNSS dependencies with LEO constellations?
So for that also, as I have worked, especially on the telecommunication satellite, I do not have some big view about the vulnerability on the GNSS dependency with the LEO constellation. So the only thing I have in mind is if we take some hosted payload with GNSS transceiver, there is a link with the onboard segregation we need also to provide. But for this, especially, we can have later on a discussion with some people, for example, from Thales Space that are here that can provide to use this answered.
But this is another invitation to join and meet the people at the booth up there. But not yet. Thank you very much, Franck Perrin.
Thank you.
We can applaud you one more.